Today, I'm going to go over what object-oriented programming is and how that differs from other programming paradigms. Hey, Code Operative here, helping you reach further faster in the programming world. If this is our first time meeting, welcome to the channel. The Code Operative channel is for developers of any level. This is a resource that will help you feel confident in your skills and solutions. Now, if that sounds appealing, go ahead and hit that subscribe button, the bell, and keep on watching to build your programming muscles every day. Alright, so let's get started. Procedural programming is basically a set of instructions. You can consider it like you're telling the computer, okay, do step 1. Now do step 2. Now do step 3. Now do step 4. So when you think about the earlier program that we wrote, it was all in one section. We said, set the variable, check the variable, get user input, etc. So here we were telling the computer exactly what to do. Do A, do B, do C, all laid out. And so this is okay when it comes to small programs, but the problem comes in when you try and create large-scale programs. Then you have this huge list of code, and a lot of it is copied from one place to another because you need to reuse code. But if you're doing it procedurally, that means you're not using objects. So it just becomes like a huge mess. You're copying things, and when you change things in one place, you might forget to change it in another place that you copied it to. Or, you've renamed something and, oh, well, that thing is used way down here in the code, and you eventually get what's called in the development community spaghetti code. The reason it's called spaghetti code is because it's a big tangled mess, basically. It's very hard for people to work with that code after you're gone, and even you looking at that code after you haven't touched it for a couple weeks will curse yourself as you try and remember all of the terrible things that you did to get that project completed. So object-oriented code is code that follows 4 basic principles. You have abstraction, encapsulation, inheritance, and polymorphism. So the first thing you need to know about object-oriented code is that it comes with objects. So what is an object? An object is an instance of a class. Okay, what is a class? Well, you can consider a class as basically a reusable set of code, right? Think of it like this box here. This box has variables, and it has methods. Some of it you can see and access outside, and some of it you can't. And whenever you need this set of things, you just instantiate it. You make it, and then when you make it, you have the object. So if you imagine the object is this weird looking car, right? So the variables could be something like number of wheels, size of the windshield, make of the car, model of the car, right? Methods could be like press gas, and after the user presses the gas pedal, then the car does a bunch of stuff, and eventually it starts moving forward. You don't know what all that stuff is unless you know the basics of cars. And then you could say, oh, switch gears. All right, now we're in reverse. Now I'm going to press the gas pedal. Oh, now I'm going backwards, right? So we're changing these variables. We're calling methods, and things are happening. Abstraction means that you use simple things to hide all of the complex things, right? So you press gas. You press the gas, it does a bunch of stuff. All of that is abstracted. All you know is that when you press the gas, you drive forward. You don't need to know all the details. And other people can easily use this class. Encapsulation refers to specifically modifiers that determine the access level of variables and methods. All right. So in encapsulation, this is referring to a bunch of different access levels. Okay? There's public, protected, no modifier, and private. And these tell you whether or not variables and methods are exposed at certain levels. So if we go with the easiest one, which is public, it's exposed at the class level, so other classes. So it's exposed at, no. So encapsulation refers to different access modifiers like public, protected, no modifier, or private. So these encapsulation refers to access modifiers, these little words that determine whether or not a variable or method is visible at a certain level. So let's go over what levels are visible based on which modifier it is. So is it visible at the class level? Can it view itself? Yes. Is it visible within the package? So basically the folder that holds the current class? Yes. Is it visible in the subclass? This is something I'll talk about later, but basically think of it like a class that comes from this class, like a little baby class. Yes. Can everybody else see it other than these things? Yes. Okay, what about protected? Can the class see it? Yes. Can the package see it? Yes. Can the subclass see it? Yes. Can everybody else see it? No. So what if you have no modifier? If you haven't put a modifier in front of it, like public or protected, what kind of access level does that give you? Well, you can access it in the class. So let's put a check mark there. You can access it in the package. Let's put a check mark there. But you cannot access it in the subclass, and no one outside of the class can access it. Alright, let's do the last one. So the last one is the most protective, which is private. So can you access it within the class? Of course, if you can access it within the class, where would you access it? Can you access it within the package? No. And you also can't access it within the subclass, and nobody else can access it. So this is the most restrictive of the different modifying levels. So the reason we do encapsulation, once again, is just to make sure that nobody outside the level that you want to be able to has access to those variables or methods and are able to mess up the flow of the object. Because as you know, most of it is abstracted out, so you should just be able to say press gas and then it does the thing, rather than saying inject fuel or move cylinder or something of that nature. So the next piece on this chain is inheritance. So inheritance allows you to kind of centralize some sort of feature and pass it on to a class that's under that class, aka a subclass. So you have a parent class that has some functionality that passes it to, you know, the different child classes. So if I was to give you an example of this, say the most common example would be, say you have an animal class and this animal class has a method called breathe, and you created a subclass which inherits from animal, let's say cat. So cat now has the breathe function without you having to rewrite it, and you can override it or whatever, and it also inherits any variables that you would put in animal, say like skin tone or fur level, something like this. This also could be applied to another subclass, something like a dog, which would also inherit these functions, and you could make them unique in their own way. For example, give this a function, retract clause, and then have dog have a function like do trick. Polymorphism builds on this concept of inheritance. So if you look at a shape, right, this is a general idea, and every shape has some way to draw it. You have a triangle and a square. Those are both going to be drawn differently. So they're going to have their own implementations of draw, which is going to override this version of draw. The point of polymorphism is you can say, you know, there's a shape, there's a shape, which equals new triangle. Triangle will have some arguments. You can now do shape.draw, right? And because triangle comes from shape, it knows that there is a draw method, whether or not triangle has overridden that method or not. So that's polymorphism. So those are the essentials of object-oriented programming from a high-level perspective. And then finally, I'll just give you a little preview on what functional programming is. So functional programming is the idea that data should be immutable, well, what does that mean? If it's immutable, it's unchanging, kind of like the final modifier that I told you about before. And functions are first-class citizens. So what does that mean? So maybe I should define what a function or a method is. So a method is something like you have your modifier, your return type, and your method name. Let's say hello. And then there are parameters that come with that method. So let's just pass it in the string name. So this is a method. And in here, let's just call a system out print line. Where we will say hello plus name. Right? So that will take in a name and append this to the string and print that out to the console. So this is the method, and then when you want to call that method, you have to say hello code operative. Okay. And now this will print out to the console saying hello code operative. So this is the method call, and this is the method definition, and this is the method header. So the idea of functional programming is that these are first-class citizens, and that you don't deal with mutable data, you only deal with functions, and any time a function modifies data, instead of modifying the thing that's passed in, it will return a new version of that piece of data. Okay. So now we have our example of a class here, and you can see at the top it says package com.thecodeoperative.demo. So this is the folder structure of the class file that we're currently in. Anything that is in this demo folder is considered to be in the same package. So if we go back to this chart that I drew here on what modifier means what, we can see that protected, everything from no modifier up is available from the package level. It's package protected. We have public, the public modifier, which is available to everyone. Class, you know what a class is. It's a collection of methods and variables. and then here's our class name. And then in this simple class, we have a private static final double named IncMax. Now this is the standard way to declare a constant value within a class using this naming scheme, all caps, words separated by underscores. So we talked about static before, but now you have some inclination of what this means. Basically, if I create multiple pens, if I have a red pen and a blue pen, both of these pens are going to refer to this same value. It's not going to be a value that belongs to the red pen or the blue pen like these other variables. So if I talk about these other variables real quick, we have our private double current ink, so the current level of ink in the pen, and then private string color, right? So if we go back to our red pen, blue pen example, so the red pen is going to have its own level of ink and its own color versus the blue pen, which is obviously going to have blue ink in a different ink level. But they are both going to have the same ink max, and that's because it's held at the class level. It's not held by these individual instances of the class, the objects. Alright, so the next piece we can talk about is the constructor. So this is what you use to instantiate the class. This is just a description, so it's a public constructor. It's accessible to everyone. It is a constructor for the pen class, and it takes in the arguments of a string color. So the reason you can tell that this is a constructor is A, it has the same name as the class, and B, it does not have a return type. Okay. So what does this constructor do? Well, it calls this dot color equals color. What does this mean? Well, this refers to the current instance of this class. For example, the red pen. So I'm setting the red pen's color equal to color. And this color refers to the variable that's being passed in this case, red. So initially it starts off where color is set to nothing. And now somebody has passed in red. They've said new, which is the keyword that you use when creating a new class, and then pen, which is the name of the class, also the name of the constructor, passing in red, right? So it's setting the color equal to this string. Okay? And then it's calling this dot current ink equal to ink max. So it's setting the current level of ink of this pen equal to the maximum amount allowed, which is a constant stored on the class. So now the pen has its own ink level, which is currently the max. Now, say that you call string.write, where you pass in a character like C and a font size of 10. Okay? So now we do red pen dot write. Passing in the letter C and the number 10. Okay. So what is this going to do? Well, it's going to set the current ink, which is currently the ink max. Let's get a different color in here. So the ink max is set to 100. And now it's going to be set to itself minus the font size, which is 10, divided by 100. So now, if we continue with the math, we have 100 minus 1/10, which is 0.1. Okay, so 100 minus 0.1, the ink level is now 99.99. Okay, and then we do a check. If this .current ink is less than 0, is 99.99 less than 0? No. Return an empty string, but it's not less than 0. Okay, so we're going to return instead a call to this function, draw a letter, passing in letter. Interesting. All right, so we know that whatever we get back from draw a letter, that's what we're returning from this function. So let's go to draw a letter. It's a pretty simple function. It takes in the letter that we passed in, C. So we've called draw letter, passing in C. So this returns the string value of letter. Oh, what does string.valueof do? Well, I haven't told you what it does, but hopefully you can guess it from the name of the function and the class it's coming from. String.valueof, passing in a character. So take this character and turn it into its string equivalent. So it just returns C. Another public function, this is called a getter. A public, where all it does is return the value of some member variable. Public string get color, return this dot color. So this is all standard naming conventions. When it's the accessor, the one grabbing the value, then you prefix it with get. So public string get color, and we're using camel case, which is the first letter is lowercase, and all subsequent words start with an uppercase letter. So lowercase get, uppercase C for color. And then we have our setter, also known as a mutator, where this function changes the value of color. So this is a public function that does not return anything, called setColor, which is again the naming convention. Prefix the member variable by set, and it takes in an argument of string color. Okay, so what does this do? This sets this dot color equal to color. So if I was to say red pen dot set color blue, this red pen would now have an ink level of 100 and a color of blue. So the reason you would want to use getters and setters is to hide the access of these member variables and only access them within protected channels. So you'll notice that there is no getter and setter for current ink. And the reason for that is we do all of the modifications to current ink within the class. I could get a getter for current ink. I just didn't do that. But there's no reason to have a setter for current ink, because if you change the color, that's going to change the ink amount, and if you write, that's going to change the ink amount. So having another way to change the ink amount could mess up the flow, and so you should minimize that as much as possible. So now you know all about object-oriented programming and how it differs from other programming styles. Let me know in the comments below what the most complicated object you can think of is.